Okay, so check it out. We've got the pupil data for everyone now, for all the subjects. I made it do a little loop, and it did what I showed you before, but now it does it for everyone. And it's quite nice. You see the pupil data. This is averaged across all 40 trials, taking each trial and taking the average across all 40 for the first 500 milliseconds or so, I think, or 600 frames, and the last 240 frames, the last 2 seconds. So you can see, like for this person, the average is going kind of straight for a while, and then it jolts up a little bit and stays on that. This is the end, and this is the beginning of each trial. The first 5 seconds of each trial and the last 2 seconds. I kind of just put them next to each other and cut out the middle stuff. I had to do that because different trials are different lengths for different people. So to get a comparable thing, I just took the last 2 seconds of the first 5 seconds because everyone has that. Not everyone has second 8 through 9. Not everyone has second 13 through 14. So I made it relative to the end and relative to the beginning of the trial to be able to look at all the data. So I just want to show you a couple things here. This is a really good way to find people that we should not have in our data set. I hope we excluded subject 600, for example. This looks really bad. Let's make sure that person's out of there. Subject 580. I hope we excluded that person in our analysis before because they also look bad. Get back to me about that. And 375 looks a little funk. I don't know what's going on here. You might want to get rid of them too. Next thing I'm going to do is average all the people that took oxytocin and all the people who didn't and see how that looks. I guess I'll just keep you along for the ride here. So what did I say? 600 and 375? I actually want to get rid of them from my... excluded subs equals. And I'm going to make a list. 600, 375. Now I'm going to make sure to delete them from my little list here. Do you see any? Yep, 375, gone. Why don't I see 600? Okay, 600 is not there anyway. I don't think. I know they're up here, but I don't see them here. So I've already divided them into what I call NOTI and OT. Looks like not also, but it's people who did not take oxytocin, people who did take oxytocin. I'm just going to run 2 separate loops. One loop for the oxytocin peeps, and one loop for the non-oxytocin peeps. I'll comment out that other thing. So this is where the money shot is. So we got a for loop for n equals 1 to the length of no t subs. We're going to load the files and just calculate a mean position. And then we're going to put the start and the end together. I subtracted a constant for everyone. So for example, you notice that some people have a big pupil, 60. Their pupil is 60, whatever units we have. And then it goes down and then it goes up for each trial. Some people have a small pupil, 38, and then it goes down and then it goes up for each trial. I took the average size across the first 10 frames and subtracted that constant from all the rest of the data so that now everyone starts at 0 and then go down and then they go back up. So it's it doesn't take into account your average pupil size, which varies a lot across people and adds noise to the data set. And it focuses in on what your pupil is doing in response to the stimulus. Maybe it will turn out that people who took oxytocin just have really big pupils. We can look at that too, overall. But I don't think so. I think we might have actually looked at that already. And so I subtract that constant. That's what's going on here in this line. So we do that little for loop for the people who didn't take oxytocin, people who did, and then we make a little graph. And that should work. Let's see if it works. Probably gonna be now. Because I just did a bunch of this code quickly. Just forgot to add add something over the name of one of the variables. I'll try it again. Probably another stupid thing. Constant OT, where are you? Oh, okay, so we got an in. Did the no T's first, then we go down here and get the OTs. Now what do we got? Doesn't like it. Line 42. So that's 600 columns. I think that's what I meant to do is make the nth row equal to that. So now it'll be a 600 column row. That'll be this average across 40 trials for each subject. Each row will be a different subject. And we'll just have to do the same thing for the OTs. That's an indexing problem. Took me a long time to learn how to get decent at that. Indexing stuff that makes your brain hurt. What's your beef? Oh, okay. No T subs. Should be no T subs. Sub ID equals num2 string no T subs. You know, if you don't care about programming, you can just totally not watch this. But if you want to learn how to do some programming, it's a great skill that really can set you apart in a lot of different work environments in graduate school. So if you want to try to play along and see if you can troubleshoot this, most of programming is troubleshooting, a lot of it. So let's see if we can figure this out. So what I'm doing is trying to run the program. Every time it throws an error, I fix it one by one, and eventually there's not going to be an error. There's left, and it's going to work. So line 33, it says it can't load this file. It says end pupemat 589. Okay, let's take a look. I made these files. Is it true that there's no 589 present? There is no 589 present. One wonders why. But yeah, it's wonderful. Yeah, this one. 589. No. I'm gonna go back to my Excel sheet. Why did I enter subject 589 if we don't have data on 589? I took it right from this whole thing. There's no data. Why did I put that in? Oh. 556 as well. Good, I don't see 600. Well done. 4375. So we didn't realize this before. Good. Okay, so sorry, 589. I think I should get rid of all these people, right? 554, 589, 556. Let's get rid of 589 first. 589. Add it to the excluded first. Excluded list. Who else? 554? Stinks these are in order. Who else? 554. I'm just getting rid of the people that don't have pupil data that presumably are going to throw it out. 556. 467. It's 476. So 467 less. I entered these manually, so I'm nervous that I'm going to mistake fat finger line. We shall see. 559. I think that's it. Okay, so now clear. Let's try it again. Yeah, okay, what's your problem, buddy? Now let's see. I like to see what number we're on. Okay, we're going through a loop here. So the first time we go through the loop, we successfully load the stuff, we compute some things, but then we get to line 54, and we got a problem. Undefined variable, constant underscore OT. Well, what? Oh, because it should be constant no T. No. It should be constant OT here. I see. We already went through the no T's successfully. That's really good. So, I don't want to be too optimistic here, but it seems like. Okay, 585 evidently. Is there really no 585? Let's look at our Excel sheet. 585. I don't see a 585 here. Okay. I don't know why they're on my list. Ah! There's a gigantic stink bug right in my computer. Oh, these things are everywhere. All right, so sorry for the distraction. Get rid of subject 585. Solution for now. Yeah, they weren't in my other list. From whence they came. 515. I entered them after subject 515. I just wonder if I fat fingered it. It should be another number. Let's take a look. Where's subject 515? Right there. I see no 589. 585. Ah! No, it's not got it. It's not my monitor. He's going to run right over the camera in a minute. You won't see his leg. Exciting times. $574, evidently. Also fiction. Okay, he's walked past the thing. I don't know if you saw him. He's on the other side of the monitor. What do these things do? Oh my gosh. Okay. Oh, yes. That looks good. I like it a lot. That's the average. The red is oxytocin. The black is no oxytocin. It's the average. Of course, the problem is that the reds are kind of hiding the other ones. Let's also make it, instead of the standard deviation, let's do the standard error. Because it looks a little, it looks like there's no, like they're totally overlapping, but I think if we get rid of this, make it standard error and not standard deviation, we'll see the differences maybe. There may be differences, even though now it looks like there's not. So what we're going to do is just normalize group standard deviation. Okay, so I'll just say normalized group standard error no t equals normalized group std no t divided by, you have to put dot divided by when you're dividing a whole matrix by something, or in this case just a vector, which is one row of the matrix, divided by the square root of however many rows there are for normalized master no t. All one. Yeah. So not how many columns, but how many rows it has. That's how many subjects it has, basically. I've perturbed it. It's giving me an error. I need one more parentheses there. Yeah, good. And then we'll just. Sorry, this is getting long. 16 minutes. That's what I get. I'm trying to squeeze in one more thing. Like everything in research, it takes a lot longer than you thought it would. Everything that takes longer than you thought it would, times pi. At least that's my. Let's try this. Oops. Okay. It didn't work because it's the same thing as before, because I forgot to update the graph to use that variable I just created. Not the standard deviation, but the standard error. Unfortunately, it's a pretty quick program to run, and oh my gosh, look at that. That is cool. That looks just like from the paper that you guys showed me. And I'm utterly convinced that there is nothing there. I'm also utterly convinced that my whole theory of the pupil is going to constrict when you realize it's fear is false. I mean, look at the average. For the oxytocin people or the non-oxytocin people, this is all the people in each group, so 20 people in each group roughly, average across 40 trials each. There's no hint of, on average, this thing going down or up in the last 2 seconds. This is the last 2 second section here. It doesn't do anything. The pupil stays the same size for the last 2 seconds, basically. Slight upward tick, ever so slight. So there's absolutely, my whole theory was, I think it made sense rationally, logically, but empirically it does not seem that is what happens to the eye in human beings in this task. So I think we'll be better off actually probably, I don't know, maybe there's still something interesting there, but we're essentially comparing this to this, and we've got this difference in depression from here and here. But I think, another thing we can do is group by depression status. So all we need to do is run the same program, switch the subject ID groups, and make it be the depressed people versus the non-depressed people. And we can get a nice little graph there. We could do the same thing with people that are high on social anxiety and people that are low on social anxiety, something like this. But this is cool, very cool. I don't know if this makes sense to you folks, but let me know. If not, we can always talk about it tomorrow too.